Good morning, class. This is Miss Browning here. You should be watching this today in class. Today is Friday the 30th, so we are going to be learning how to name acids and draw E-dot and structural formulas. Okay, so make sure to look on the whiteboard today and take a picture of that. You do have some homework over the weekend. Specifically, the naming and formula writing worksheet on page 24, that's going to be due on the next time I see you. So that's Monday, the December 3rd, I believe. So make sure you're looking at that this weekend. And then go ahead and get started on the problem bank, questions 1 through 10. That's going to be due on the 7th of December. And after today's lesson, you should be able to get on page 23 and do the structure practice worksheet, and only do the ones that are circled, which include number 2, 3, 4, 7, and 8. And only do the structural formulas only on that worksheet, and you're going to do so on a separate sheet of notebook paper. And if you want one of these calendars, they should be at the front on the honors chem table, so make sure to pick one up before you leave if you want one. Okay, so I'm going to give you all a few moments to go ahead and get out your note-taking guide and your covalent bonding packet. Go ahead and get both of those things out. I'll give you a few moments. It should not take long. Okay, so note-taking guide and covalent bonding packet. Okay, if you already have your note-taking guide out, go ahead and flip to page 4. Page 4 in your note-taking guide. Okay, so it should look like this. Page 4. Okay. So you can see the first thing I'm going to be teaching you is how to do E-dot and structural formulas for covalent compounds. I did not personally make a video to teach you how to name acids. I have, however, posted a video to Google Classroom that teaches you how to name the rules to naming acids. Okay, so please make sure to look at that on your own time. It will be on your Google Classroom. All right, so let's go ahead and get started. So the steps for drawing E-dot diagrams and structural formulas for covalent compounds. This is at the top of page 4 on your note-taking guide. Okay. You also have those down here, the steps for drawing E-dot and structural formulas. This is copy and pasted directly from the PowerPoint slides. I will also upload the PowerPoint slides that go with this lesson to Google Classroom, so look at those if you need. Okay, so the first step is to calculate the total number of valence electrons. We know that that is definitely the first thing we need to do. To draw E-dot diagrams, you have to know how many valence electrons an atom has. Okay, so we know that the group numbers at the top, the A group elements, that group number tells us how many valence electrons an atom has. And we're dealing with covalent compounds right now, so we're mostly going to be dealing with the non-metals on the right-hand side of the periodic table, and of course hydrogen in group 1A. We know that's the only non-metal over here. Okay. So to calculate the total number of valence electrons, we need to look at the group number. Okay. The second step is to choose the central atom. Now the central atom is going to be a singular element or one that forms the greatest number of bonds. So in other words, the central atom is the atom that you have least of in your compound. Okay. Or it's going to be the atom that has the least number of bonds. Now remember, the group number, you can tell how many bonds an atom can make based off its group number. Okay, group 7A elements can only form 1 bond. Group 6A elements can form 2 bonds. Group 5A nonmetals can form 3, and group 4A, they can form 4 bonds. Okay, and hydrogen can only form 1 bond. Okay, and that's all based on the number of valence electrons that aren't being paired up. Okay, the third step is to join atoms with single covalent bonds. A single covalent bond represents the sharing of 2 electrons. And then the fourth step is to complete octets with leftover valence electrons. use double and triple bonds if you run out. I'll tell you what that means here in just a second. I'll show you what that means. So let's go ahead and do the first problem. If you need a separate sheet of notebook paper, because this is not enough space, that's totally fine. I'm gonna have to write small, so maybe I should zoom in a little bit. Okay, so H2S. Okay, so the first thing we're gonna do is go ahead and name this. These are both non-metals, so we know we're gonna have to use rules for naming covalent compounds. So if it's a covalent compound, we need to use prefixes. So this is gonna be dihydrogen, because there's two hydrogens, monosulfide. Okay. All right. So we're going to draw the E dot now. So the first thing we need to do is, before doing this, is to calculate the total number of valence electrons. There are two hydrogens and one sulfur. So each hydrogen atom has one valence electron, and there's two of them, so that's two total. Okay, and then sulfur has 6 oxygens. So 6 plus 2, that's going to equal 8 valence electrons. All right, second step is to choose the central atom. And FYI, down here in these rules, it tells you that the central atom will never be hydrogen, okay? So this dihydrogen monosulfide is made up of 2 hydrogens and sulfur, so that the 2 hydrogens are automatically canceled from being the central atom, so it has to be sulfur. So here's sulfur, and we're gonna connect our atoms. The third step says to connect our atoms with single covalent bonds. So we have sulfur in the middle and 2 hydrogens, and they're connected by a single covalent bond, which represents the sharing of 2 electrons. Okay. Fourth step is to complete octets with leftover valence electrons. Now we're always going to look at the outside atoms first. Okay. So our outside atoms, can we add any more valence electrons to hydrogen? Well, no, because hydrogen only needs 2 valence electrons, and it already has those 2, okay? So we move to the central atom, and we can see here that sulfur only has 4 valence electrons around it, and we need 8. We need 8 valence electrons total, so we can go ahead and add those around the sulfur. And now we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, okay? And indeed, sulfur now has a full octet, 1, 2, 3, 4, 5, 6, 7, 8, and each hydrogen has 2 valence electrons, okay? And that's how covalent bonds work. They share their electrons to be stable. Okay, so that's the E dot part of it. The structural formula is very similar to this, but we're going to turn those shared pairs of electrons into a single covalent bond represented by a dashed line, basically. So this is going to look like this. Okay, those shared pairs of electrons we know is represented by a dashed line. Each line represents the sharing of 2 electrons. So this is a single bond. Okay. Next one, I'll give you all a few moments to write this all down, and then I'll move on to the next one. Next one we have phosphorus and hydrogen. Okay, this is pH3, so the name for this would be phosphorus because there's 3, and then this is hydrogen, so trihydride. Okay, the next thing we need to do is calculate the number of valence electrons that are here. So we have a phosphorus and 3 hydrogens. Phosphorus is in group 5A, so it's going to have 5 valence electrons. Each hydrogen has 1 valence electron, and there's 3 of them. 1 times 3 equals 3. So we're going to take 5 plus 3, that equals 8 valence electrons. Okay? So in our E dot diagram, we should have 8 total, just like we did up here. Okay, so next is to choose our central atom. It can never be hydrogen, right? So it must be phosphorus. So phosphorus is our central atom. And now step 3 says to join atoms with single covalent bonds. Okay. Steven, shh. Sorry, my dog is barking. Okay. We need 8 valence electrons, and right now we only have 6. 1, 2, 3, 4, 5, 6. So the 4th step says to complete octets with leftover valence electrons, and we're going to look at the outside atoms first before moving to the central atom. All of these outside atoms are hydrogen, and they only need 2 valence electrons, so we don't need to do anything there. So now we can move to the central atom and add those leftover electrons around it. And now we have 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons, and everything is stable. So we turn those shared pairs of electrons, which are right here and right here and right here, and we turn those into single covalent bonds with P as our phosphorus as our central atom still. Okay. All right, next one. I want you, I'll go ahead and do this one with y'all. Okay, so we won't be asking you to name atoms with more than, we won't be asking you to name covalent compounds with more than 3 atoms. So let's just go ahead and count the number of valence electrons for this. We have hydrogen, carbon, and nitrogen. Hydrogen has 1 valence electron, carbon has 4, it's in group 4A, and nitrogen is in group 5A, so it's going to have 5 valence electrons. This is a total of 10 electrons, 10 valence electrons. Okay, so in our E dot diagrams, we should have 10. So what is the central atom going to be here? Well, we know it's not going to be hydrogen, and between carbon and nitrogen, our carbon atom is the least electronegative, so that actually is going to be our central atom. Okay, and we'll learn more about that determining electronegativity next week. Okay, so now we're going to join our atoms by single bonds. Okay, so we have 4 valence electrons so far. We need 10, so there's still 6 left over that we need to put somewhere. So we're going to start with the outside atoms first. Hydrogen doesn't need any because it only needs 2. So I'm going to go ahead and add as many as I can around the nitrogen. So we have 4 and we need 10. So 5, 6, 7, 8, 9, 10. Okay, so now I have 10 valence electrons. So let's see if all of our atoms are stable. Hydrogen looks stable. Nitrogen has 8 around it. That's good. So let's look at our central atom. Carbon only has 4. Okay, so we're going to have to do something here. All right, so on the last step here, it says use double and triple bonds if you run out of valence electrons and your central atom still needs a full octet. So what we're going to do here, it doesn't matter which pair of electrons that we take, but we can just take any of these 2, any of these 3 pairs, and put them in the middle between carbon and nitrogen. Now, why did I pick 2 pairs? Well, because carbon still needs 4 more electrons. 2 pairs equals 1, 2, 3, 4, 4 electrons. So by putting those in the center, let's see if that's going to work out. Okay, so this would really look like hydrogen, carbon, and then 3 pairs of electron between the carbon and the nitrogen. We still have those 2, that lone pair of electrons outside of the nitrogen that we did not have to move. So that's still there. Okay, so now hydrogen has 2 valence electrons. So that's good. Okay, the nitrogen has all of this right here. That's 1, 2, 3, 4, 5, 6, 7, 8. And the carbon has those things as well. Has those valence electrons as well. 1, 2, 3, 4, 5, 6, 7, 8. All atoms are stable now. Okay, so the actual structural formula for that is going to look like this. Hydrogen is bonded to carbon by a single covalent bond, and carbon and nitrogen are bonded by 6 valence electrons, the sharing of 6 valence electrons. So that's going to be a triple bond, because each line here represents the sharing of 2. And if there's 6, then we need 2, 4, 6. We're going to need 3 lines to represent a triple bond. And don't forget that lone pair of electrons that goes around the nitrogen. So this is what our structural formula looks like for HCN. The next one, we have 2 carbons and 4 hydrogens. So this is we're gonna need to use our prefixes here because these are both nonmetals. This is dicarbon, tetrahydride. Okay. So now we need to count how many valence electrons we have. We have 2 carbons and 4 hydrogens. Each carbon has 4 valence electrons, and there's 2 of them, so 4 times 2 equals 8. Each hydrogen has 1 valence electron, and we have 4 hydrogens here. So 1 times 4 equals 4, and that gives us 12 electrons, 12 valence electrons. Okay. So carbon is going to have to be our central atom because hydrogen can't ever be the central atom. And there's 2 carbons, so we're going to go ahead and make both of them our 2 central atoms here. And we're going to connect those by a single covalent bond, which is what step 3 says to do. And then now we're going to go ahead and do that for the other hydrogens. So I'm just going to go ahead and put those at the top here, 1 at the top of this carbon. So 2 on each carbon, basically. All right. So that gives us a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 12. Okay, so we need 2, we have 2 left over that we still need to put somewhere. Now we know that the hydrogens can't have any more because hydrogen only needs 2. So now we're gonna move to the central atoms. And we can't put 2 here because that would make this carbon stable, but this one would still need 2 as well. So what we're gonna do is put them right in the middle. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So what happened here was carbon formed a double bond with the other carbon atom, and we have single bonds. Oops, I need to turn that into a single covalent bonds. Okay, we have single bonds between the hydrogens and the carbons. Okay, so you can see here that hydrogen and carbon are only sharing 1 pair of electrons, but there's 2 pairs of electrons between the 2 carbons, which is represented by a double bond. Okay, next one we have 1 carbon and 1 oxygen. Now we know we're never going to use the prefix mono on the first atom, so this is just going to be carbon monoxide. Okay, now we are going to count our valence electrons. We have 1 carbon and 1 oxygen. Carbon has 4 valence electrons because it's in group 4A, and oxygen has 6 because it's in 6A. So 6 plus 4 equals 10 valence electrons. Okay, so carbon and oxygen, well, you must be thinking, well, which one's the central atom? There's only 2 of them. How can there be one in the center? Well, carbon is actually going to be more or less electronegative than oxygen, so that's going to be our central atom. Okay, and that's going to come into play here in just a second. So we have carbon. We're going to single bond that to the oxygen. Okay, so that gives us only 2 valence electrons, and we need 10. So what we're going to do is put the leftover valence electrons on the outer atom first. So technically, oxygen is our outer atom. Okay, so I'm going to do 1, 2, 3, 4, 5, 6. That's still only 8 valence electrons. I can't put any more around oxygen. So maybe I can, move to the central atom and add 2 there. And now I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oxygen is stable, okay, but the carbon is not. Carbon only has 4 valence electrons. Okay, so again, we're going to have to move electron pairs from the outside atom into the middle between carbon and oxygen so that they can share. Now carbon needs 4 more. 1, 2, 3, 4. It has 4 right now. It needs 4 more. So this would be 5, 6, and I would still need 2 more to put in the center. So really that's going to be 1 carbon with 6 shared electrons between the carbon and the oxygen. Okay. So this is six electrons being shared between the carbon and oxygen, and that is represented by a triple bond. Now we can't forget the lone pair of electrons around the oxygen that isn't being shared. That still needs to be included in our final structure. So this would be carbon monoxide, the structural formula, where carbon and oxygen are connected by a triple bond, and we have those lone pairs of electrons around each atom. And now carbon has 8, 1, 2, and then 6 here, 3, 4, 5, 6, 7, 8, and oxygen has the same as well. Both atoms are stable with 8 valence electrons. Okay. Okay, the next one, I'll just let you know, this is methyl chloride. I don't think you need to know that, but I could be wrong, so just go ahead and write it down just in case. This is methyl chloride. Okay, so now we need to count valence electrons. There's a lot of these. There's 3 different atoms here. So we have 1 carbon, 3 hydrogens, and 1 chlorine. The carbon atom has 4 valence electrons. Each hydrogen atom has 1 valence electron. And there's 3 of them, so we need to multiply that by 3. Chlorine has 7 valence electrons. So together, 7 plus 3 is 10, plus 4 is 14. Okay. So again, which one is going to be our central atom? We know hydrogen can't be the central atom. And carbon, between carbon and chlorine, carbon has is least electronegative, so it's going to go in the center. Now we're going to connect our atoms, our other atoms, to carbon by a single covalent bond. So we're going to have 3 hydrogens and 1 chlorine. So I'll just go ahead and put all the hydrogens like right here. 3 hydrogens and 1 chlorine. Okay, and carbon's good to go. Carbon already has 8 valence electrons, so that's cool. But we need 14, and we only have 8 so far. So we need 6 more. So let's look at the outer atoms. We know hydrogen won't need any more, so we're going to put those 6 leftover valence electrons around chlorine, which is exactly what we need to do to make chlorine stable. So now carbon is stable with 8 valence electrons, chlorine is stable with 8 valence electrons, and all the hydrogen atoms are stable with 2. So we can see here that carbon is our central atom, and every atom around it is connected to it by a single covalent bond. Okay, now we can't forget about those lone electrons, those lone pairs of electrons around the chlorine. We have to include those. Okay. Next one is a little tricky, so pay attention. This is a polyatomic ion. Okay, so this is chlorate. Right, we have chlorate has a -1 charge, and that's going to come into play here in just a second. So we have chlorine, which has 7 valence electrons, and we have oxygen, we have 4 of them. And each oxygen has 6 valence electrons. Okay, so 6 times 4. And do not be mistaken, this is an O. For those of you who might be watching this later, this stands for oxygen. Okay, so it's not 40. So 6 times 4 equals 24. Okay, so 24 plus 7 is going to be 31. Is that the total number of electrons that chloride has, though? No, it's not. Chloride has a -1 charge, which means it's gained an electron. So we need to add plus 1 electron at the end. So 7 plus 24, that's 31, plus 1, that's going to give us a total of 32 electrons. Okay, so make sure you're not forgetting that. Okay, we had to add that extra electron before doing our EDOTs. Okay, so chlorine, this is a perfect example of when we can just use the rule, use what you have the least of to choose your central atom. So we clearly have less chlorine than oxygen. We have 4 oxygens and only 1 chlorine. So chlorine is going to be our central atom. Okay, now we're going to connect all of the other atoms to chlorine by a single covalent bond. And there's 4 oxygens, so I'm going to put 1 on each side. All right, so We need 32 electrons, yet we only have 8 so far. So we're gonna look at the outside atoms first and fill those in one by one. So I'm just gonna start counting. I have 8 so far, so I'm gonna start off at 9. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That works out perfectly. So we can see here, each oxygen atom has 8 valence electrons around it. And the chlorine atom, the central atom, has 8 valence electrons around it as well. Okay, so each atom is bonded to each other by a single covalent bond. So it looks like this, and we cannot forget to include those lone pairs of electrons around the oxygen. Those have to be included in the final structure, in the formula structure. Okay. So that would be chlorate. Okay. So the next one we have NH4 plus. Okay. Let's go ahead and get started. This is ammonium. Okay. Just one moment. Okay, I haven't done this one yet, so we're doing this like together for the first time. So let's go ahead and get started. We have nitrogen and 4 hydrogens. Nitrogen has 5 valence electrons, and hydrogen has 1. There's 4 of them, so 1 times 4 equals 4. And we have a +1 charge. Okay, so let's see if that comes into play here in just a second. So far we have 9 valence electrons. And nitrogen is going to be our central atom because hydrogen can never be the central atom. Okay, so we're going to connect those hydrogens and nitrogens together, or that nitrogen and hydrogens together by a single covalent bond. Okay. All right. So far we have 8 valence electrons, and we're supposed to have 9. Okay. Can we add any more electrons around the hydrogen atoms? No. Hydrogen only needs 2 valence electrons. Can we add any more around the nitrogen? It already has 8, so no, we can't. So really, this is not the right number because ammonium has a +1 charge, which means it lost an electron. So we need to subtract 1 from here, and that would really give us 8 valence electrons, which is exactly what we have. So this is right. We don't need to do anything else. So this is going to look like this. Nitrogen as our central atom, and each hydrogen is bonded to nitrogen by a single covalent bond. All right, we're not going to be doing this one together. You're going to do this one on your own on page 24. So I hope this helps. We'll touch base on this again next week. Make sure to look at, I'm going to have the sub. You should have been watching this in class together, but if not, I'll be posting this to Google Classroom as well. So make sure to look at this and practice, and also watch the naming acids video as well. Don't forget you have homework. Make sure to look at the whiteboard to see what homework you have for the weekend. All right, guys, I will see y'all on Monday. Have a good weekend. Bye.